We've created a couple of students, we created a couple of sections. Let's see if we can create a relationship between these two, right? So for instance, let's see if we could maybe have a student enroll in a section, right? So let's try and do that. So from the student's point of view, what I'd like to be able to do, right, is you tell me, which students is enrolling in which section, right? So something like public returns the students that that was enrolled, and we'll say enroll student in section. For that, I'll need to know which student and which section, right? So let's do that. We can maybe provide the IDs, the primary keys of both of them. We can say, if you tell me the integer primary key of the student ID, and you tell me the primary key of the section, I could probably find them, right, and then create the relationship, right? So the way we're going to do this is that we're going to retrieve both of them. We're going to retrieve the sections and we're going to retrieve the students, and then we'll create the relationship between the two, right? In a one-to-many relationship, it was what? It was you retrieve the parent, you retrieve the child, and then you say, hey, child, now I am your parent. And the parent would say, hey, I'm going to add this child to my list of children. Okay, so it was doing those two things. Here is enough to just do from the student's point of view, or wherever you declare the join table, right? Everything has to be done from the repository where you declare the join table, right? So let's try and do that. Let's go fetch the student in the section. So to get the student, I would use the student repository, which I believe I have. There it is, student repository. So this will be find by ID. There's my student ID. I have it right there. I'm going to unwrap it, and now I have my student. Yes? I'm also going to go fetch my section. The section, and that's the data type. Yep. And I do not have the section. Repository, right? I'm going to need to do that. Whenever I am establishing relationship between two entities, I'm going to need both repositories. So let's go and instantiate the repository here as well. So this will be auto-wired, and this will be the section repository, right? And now I have it. Now I can say section repository find by ID the section ID. Right, and I am going to unwrap. There we go. Okay, now we have the student and the section. So what we're going to do is just say student dot. I'm going to grab the section. That's going to return to me a reference to the array list where I have all my sections. Yes, right. I'm just going to append to it. I'm going to say add this section. Right? That's it. That's all I need to do. I can then now go and just save the student. I can say student repository, just save the student. Save the student. Okay. Let's look at the enrollment table. Let's make sure that there's nothing in there. Let's see enrollment. What do we have in there? Okay, we have no students enrolled in any sections whatsoever, right? So let's try this out. And I'm going to return. Well, let me return null for now, because we haven't dealt with one particular thing. Okay, I'm going to return null for just for a second, and we'll come back to this in a minute. But let's try it out, right? So to try it out, we need to expose this to an endpoint where I can pass students and IDs. I guess we could hard code it. The student IDs here. I mean, we know we have two students in student 1 and 2, right? And we have sections 1 and 2. We could do that. But making it a little more interesting, I'm going to pass it as an attribute, right, in the path of the URL. Okay, how's that? We'll do again a get mapping, and the URL, a sensible URL would give me both the student ID and the section encoded in the URL, right? I could just do this. I could just do student, student ID slash and then section ID. I could do that, right? But something a little more readable, it would tell me here that std, right? How should I interpret it? Oh, that's a student, right? That's a primary key for the student. And that section over here, oh, it's a primary key for the section. Okay, so this is a little more readable, right? It also matches a design pattern or very popular convention of use called Restful Services, right? If you structure your URLs in such a way that are readable and follows these kind of naming conventions, then these are restful. This is not entirely restful because it's creating and saving content into the data. So it's doing a write into a database. So a get operation is really mostly for read. Okay. So it's not entirely a RESTful service. Almost. We'll talk about RESTful services maybe on Monday. All right, excellent. So we have that. Now we have to extract these two fields that are embedded in the URL. We need to map them to parameters here. So to do that, we could use path variable. Path variable is going to parse these variables from the path. So this one is going to parse it. We can name it here, and that gets mapped to my variable here, parameter that I'm going to pass into the function. Same thing with section ID over here. So this will be path variable, and this will be section ID. Now I'll have the values. I can then do the enrollment. All right, let's try it out. Okay, so let's restart the server. All right, so we have that. Let's go fetch again the enrollments. There are no enrollments. I have no enrollments. Notice that when we do the enrollment, the student table and the section table are completely oblivious to this enrollment, right? It is being entirely being managed at a separate table, the enrollments table. Even though, right, from Java's point of view, notice that there's no mention here of any enrollment table. See that, right? All that is being managed underneath. Right? The fact that there's a join table, it's only a detail that is specific to SQL. If we were using JSON, right, as a database, right, Mongo or any of these non-SQL databases, non-relational databases, this would be, in JSON you can have a field that is actually an array, right? So this would be perfectly fine. You're adding just lots of foreign keys in an array of foreign keys. Perfectly fine. But in a relational database, there's no such thing as an array, right? So you have to have a separate table where you are keeping track of all these values. Yes? And that's why thinking about this at the object level, it's not so far-fetched, right? And the fact that we're using a table as a mapping mechanism is only because of the limitations of relational databases. Make sense? Right? It's only an implementation detail which is being hidden here from us. Notice that the enrollment table plays no role, right, in our management of students and sections, even though that's the record that's going to be saved. Anyway, so did we rerun this? I forget. All right, so restart that, and let's copy this URL. And we have, let's see, what do we have for students? We have Alice and Bob, 1 and 2. And we have for sections, we have section 1 and section 2, also 1 and 2. All right, so as a URL, a sensible URL might be localhost 8080. And then students, maybe I want to enroll student 1 in section 2. Okay, so if we do that, notice that I'm returning a null for now, right? I just want to see if this blew up. Okay, it looks like it didn't blow up. It looks like what it did is that it did a couple of select statements, then it did an insert into the enrollments table. Look at that, right? So it did insert into the enrollments table, where student ID and section ID have the values. It created a prepared statement, right? And then it filled in the blanks, right, for the student ID and section ID that I passed, hopefully, so that that insert, if I go back and refresh on my enrollments table, notice that indeed we have a relationship between the student 1, presumably enroll in section 2. Everybody good? All right. All right. So let's now try and do it again, but now returning something from this enrollment.